Here we have a couple of scale diagram problems, and the first one illustrates one of the aspects of confusion around these problems. If you have two diagrams that are both essentially scale diagrams of something, in this case a house, but one has been modified based on the other, you can talk about one being an enlargement of the other or one being a reduction of the other. And so of course you have to have an original diagram and then either the enlargement or the reduction. So for this one, let's say, just for argument's sake, that the one on the left is the original diagram and the one on the right is the copy or the image. So it's an image, or we can specify that it's an enlargement. So since it's an enlargement, the scale factor is going to be bigger than 1. If we had it the other way around, the one on the right was the original, the one on the left was the reduction, the scale factor would be less than 1. So how do we determine the scale factor? Well, we need to take a measurement on both diagrams, and on my computer screen anyway, this is 4 centimeters across, and this one is 7 centimeters across. Remember, it's crucial to use the same unit, but it really doesn't matter what unit you use. We could measure this in millimeters, we could measure this in inches, as long as you use the same measurement for the two of them. So again, if we're saying that the one on the right is the image, the scale factor is equal to a fraction or a ratio with the measurement from the image in the numerator, so 7 centimeters, and a measurement from the original in the denominator, 4 centimeters. So we end up with 7 over 4. That would be the scale factor expressed as a fraction. As expressed as a decimal, we could have 1.75. Expressed as a percent, we could have 175%. And again, we could also express this as a scale, which is usually expressed in ratio form. So in this case, the scale would be 7 to 4. Or, the more common way to write the scale is 1 to something. All right, so again, just take a look at that first number. You've gone from 7 to 1, so you've divided by 7. So you have to do the same thing for the second number. So you divide 4 by 7. So 4/7 is a little bit more than half, and it's 0.57, and the decimal goes on. It's 6 digits repeating. So I'm just going to stop it right there, round it at 0.57. And again, the rationale behind that use of the scale is that you can say, well, 1 centimeter on the image corresponds to 0.57 centimeters on the original. And quite frankly, it's not all that useful for this kind of example. Much more common would be to express it as a scale factor of 1.75 or 175%. If you took the original diagram, put it on a photocopier, and dialed up to 175%, you'd get an image like the one on the right. Let's take a look at another problem. Here we have a scale diagram of the Eiffel Tower. And I've gone ahead and measured the height of the tower in the diagram, and on my screen it's 12.5 centimeters. The scale diagram, or the scale for this diagram, is 1 to 2,592. So how do we figure out how tall the Eiffel Tower is in real life? The equation that I said is very useful for these sorts of problems is that the scale, which can be converted into a scale factor, is equal to a measurement on the image divided by a measurement on the object, so the actual Eiffel Tower. So in this case, we have to convert this scale 1 to 2,592 into the scale factor of 1 over 2,592. And we can say that's a measurement on the image, the one I've taken there, 12.5 centimeters, over a measurement on the object. So the actual height in this case. So the height of the Eiffel Tower. And when you have this sort of equation with a fraction equal to a fraction, you can cross multiply. 1 times the height is just the height. And then we get 12.5, and this is in centimeters, so I should put that in there. 12.5 centimeters times 2,592. And here we see what I was talking about. When you have a scale given as 1 to a number, in this case 1 to 2,592, we can interpret that very nicely as 1 centimeter on the diagram is 2,592 centimeters in real life. And so therefore 12.5 centimeters is simply going to be 12.5 centimeters times 2,592. And that works out to 32400, so 32,400 centimeters, which is a big number, and we wouldn't normally express a height in centimeters, at least a height of something like that. We would more usually convert that to meters. And so we get 324 meters, and that's the height of the Eiffel Tower.